Hello everyone, today I'm going to show you the 2D platforming game I've been working on. I'm going to walk you through some different code examples to show you where I started on this project and how I got to where I am now. I'm not going to get too technical about specific lines of code, I'm just going to give you a basic explanation of how 2D platformers work, and show you what I did to create a game of my own. I started by doing an online search for source code. I figured many other people have already attempted this kind of project before, so there was bound to be plenty of code examples on different online forums. I was expecting to have to look at many different examples before I knew all the basics, but I was fortunate enough to find a single example that really told me everything I wanted to know. This source code is so amazing I was almost worried there would be nothing left for me to figure out. It is a very nearly complete 2D platforming game. You have a player that can move left and right, it can jump up and down, it can collide with objects, and there's a camera that follows it around wherever it goes. Apart from having a few enemies and some means of attack, this is essentially a fully featured 2D platformer. I could have started by adding some missing mechanics. Having enemies and a means of attack can do a lot for a 2D platformer. Not every 2D platformer game needs to have enemies, but I want to have enemies in my game. If I want them, obviously I'll have to code them myself, but what would be the point of adding enemies to a game that looks this boring? Instead of focusing on mechanics, I decided to start with how the game looked. In this example, I've altered some of the graphics. It might look quite a bit different, but it's the exact same game. You might think those are Mario blocks and might think that's Mega Man, but it isn't. This is still just the same square we had before, except now it's a little bigger and it has a picture of Mega Man on it. The platforms, which once looked solid, now are covered with Mario bricks, revealing that they were actually aligned blocks. Everything in the source code example is made from the same size block, including the black squares that make up the background. Adding images to the blocks is pretty easy to do. Instead of filling them with a solid color like in the source code, I just filled the blocks with an image file instead. The original player square was too small to fit the picture of Mega Man, so it had to be resized. Resizing the player increases its detectable area so it will be flush with the image. At this point in the project, I had a game that looked like a weird Super Mario level starring Mega Man, but I didn't want to make a Mario or Mega Man game. What I really wanted to make was a Castlevania clone, so I decided to do an online search for Castlevania graphics and found this pretty nice looking background. Since my example code uses 32 by 32 pixel blocks, I decided to put the background in the 32 by 32 pixel grid and see what happens. With the grid in place, it's easy to see that the background is actually made from 16 by 16 pixel blocks, but some 32 by 32 pixel squares contain a single repeating image. I decided to use a few of these images in my example. These larger tiles will still allow me to create an authentic look without having to bother recreating minor details. When the blocks are loaded in the script, they give the game a new feel, but it still kinda just looks like Mario. The Castlevania blocks look way smaller in my game than they did in the background. This can be solved by changing the game window's resolution to match the resolution of the background. If I change the window size to match the size of the background, the blocks will display at their correct resolution, but the window will be far too small to play a game in. If I multiply the size of the screen and the blocks by 3, I can increase both their sizes while maintaining the correct aspect ratio. Now we can see the game screen is much bigger, and the top of the screen is covered by 8 blocks. This is a perfect match with the 8 blocks across the top of the background image, which means it's displaying at the correct resolution. At this resolution, the level is huge, and Mega Man looks a little too small to be in this environment. That means I need to add a new sprite and make considerations about animating it. A static non-animated player is pretty boring to have in a game. Nearly all 2D platformers have an animated character. Although I'm making a Castlevania game, I decided to stick with Mega Man. Mega Man is a bit more animated than Mario, but isn't as complex as a Castlevania character. I felt animating Mega Man was the appropriate test for my skill level. I could take what I learned from animating Mega Man to create a Castlevania character. To animate a character in a 2D platformer, you typically use something called a sprite sheet. This is a giant sheet of images that contain every frame of animation used to animate a character. By loading these images to my player block, I can begin animating my character. If I use the image of him standing, he looks much better than in his original graphic. He looks more suited for the size of the level, but there is one thing I have to worry about. Parts of the image might only look transparent against the black background because the image itself is black. To make sure the image is transparent against any background, I need to change the background to include a repeating image rather than a solid color. When I change the background, the Mega Man sprite no longer appears transparent, and I have to add some code to tell the compiler to create a transparent image. With the transparency issue fixed, I can begin creating the walk loop, which will allow Mega Man to run in either direction. I did this using a range of update calls. On the first update, Mega Man is in the standing position. On the 30th update, Mega Man is in the first running position, and so on. Since the game updates continuously, you can adjust the speed of the animation by deciding how many updates should go by before it changes the image. In this example, Mega Man is able to run left or right, but he'll remain in this position whether he's in the air or just standing still. To complete the animation, I need to create a loop of animation for every position Mega Man can be in, one for whether he's running, standing still, or in the air. If I add these animations, Mega Man will appear to fall when he's in the air. He can run left and right, and if he stands still long enough, he'll blink. Now what I have is essentially a fully animated character, except that he can't attack. The character sprite currently uses 14 frames of animation, but to make the character attack would require 10 more frames, which is nearly as much as I'm already using. Positioning the sprite sheet on the player square was quite tedious and time-consuming. So before adding more information, I created a utility to make adding new frames a lot easier. Originally, I used MS Paint to find the rough location of each frame of animation on the sprite sheet, then loaded it into the game over and over with different values until I found the correct size and position of the sprite. This utility takes the guesswork out of finding the position and size of each sprite on the sheet. A set of arrows can move the sprite sheet into position, and another set of arrows can resize the frame. When I hit the spacebar, the program will ask for the name of the sprite I'm trying to map. After I name the sprite, the program will generate code inside of a text file in the main folder. Not only does it record the position and size of each sprite, but it also generates all the drawing code needed to start using the sprite right away. All I have to do is copy the code to my script, and the game will now have a new frame of animation to work with. After adding the attack animations, Mega Man can now arm his Buster Rifle by pressing the spacebar. Everything looks good when aiming to the right, but I noticed quite a few errors when aiming to the left. Aiming while standing to the left pushes Mega Man backwards well out of his original standing position. This doesn't happen when attacking to the right. Although this might look like a minor problem, fixing it will require me to take a whole new approach to animating my player. I can't move the attacking sprite any further to the left before placing it outside of the player rectangle, which will cut off part of the image. I could move all the other images to the right to line up with the sprite of Mega Man shooting to the left, but this would create a lot of empty space to the left of Mega Man that will still detect collisions. This would look kind of awkward if Mega Man is stopped by a wall, even though he appears to still have room to move. The solution is to make the player sprite invisible, and only use this object to determine the player's detectable area. To create the graphics, I can place a large transparent sprite on the screen that will follow the player object around, and draw the graphics on top of where the player object should be. This will allow me to center my animation sprites over the player object, without being confined to the space available in the player rectangle. In this example, when I turn to the left, I've filled the transparent area with black so it can be seen. Although this sprite is always present on the screen, its actual size isn't noticed because it's mostly transparent. The only part that's filled is the sprite of my character, which is centered over my player object. As long as the images of my character are always drawn in the same area of this rectangle, they will always line up with the player object. Aligning all my sprites in the same rectangle would be pretty tough to do while simply testing them in the game. So I built another small utility to test the sprite's alignment and make adjustments as needed. If I take the code generated in my other utility, I can flip through the animations I have available and make sure they are all in line with each other. I can then modify the code as needed to align them before copying them to the game. As a small added feature, this program can also bundle frames of animation together that belong in the same loop, such as the walk loop or the standing loop. It will save more code to my text file, which will place the saved frames into an array. By adding this code to my game, the animation engine I built can flip through the elements of the array much like flipping through pages of a flipbook. This allows me to import complete loops of animation in my game much faster. After adding the newly aligned sprites to my game, you can see that everything now looks like it should. Mega Man can now aim left or right without moving out of position, and the next step would be to create projectiles so Mega Man can fire his Buster Rifle. but that will have to wait for another video. So thank you very much for watching. I hope you found this project interesting, and I hope you will tune in for the next video.